Hello everyone. Welcome to the video lecture series on complex variable and analytic functions. I'm Mayur Gohil. In this video lecture I shall be dealing with analytic functions, which is one of the major concept in complex variable. Let us see. So first of all, we understand in complex variable that we have a particular function. Okay, now this function in general we shall be talking it as f of z is equals to u of x comma y plus I times bx comma y. Now, there are many concepts when we go from the real plane to complex variable that become different, or they have certain more notions attached to it. So one such notion is differentiability. Okay, so the original definition of analytic function is something like this. If we have a function f of z like this, which is defined in this manner, okay, if we have f of z which is defined and differentiable differentiable at each point of the domain, let's say I'll call this domain R. Okay, uh, then f of z is said to be an analytic function. Okay, that is what is the definition, and this is how it is given. uh, the simplest and the most easy version. There are more technical versions of the same to be given, that we can say that if we elaborate this definition more, then we can write this as like a function, the or we can say the function f of z, okay, is said to be analytic at a point, let's say z naught. If I say this is a point z naught, if its derivative exists not only at that point, but in the delta neighborhood, right? Delta neighborhood, that would be like this: mod of z minus z naught less than delta. This is how it is at that point. Now see, this is very technical mathematical definition of analytic function. Now here some more concepts are also involved, like differentiability, derivatives and all. So what we do, we take up a much easier version which is more capable of helping us to solve the different kind of question. So for that we go for a newer and a much easier criteria that will help us to understand the definition better. So what we do, we define now something called as Cauchy Riemann equation. So let us see what are Cauchy Riemann equations first. So we now define here Cauchy Riemann equations. These are very popular and they help us to understand the definition of analytic function in a much better way. So we let f of z equals to u plus iv. Okay, and u plus iv, when we say, it is basically the meaning here, that is, it is u x comma y plus I v x comma y. That is the meaning. Okay, so, and in short it is written as u plus iv. Then Cauchy Riemann equations. Okay, then Cauchy Riemann equations are given as, I'll write here with the blue color or some nice color here. Let's see, let's do it with white. So the given is daba u by daba x is equals to daba v by daba y, and daba u by daba y is equals to minus of daba v by daba x. So this is the two equations, these you can see here. And now there is a simpler or a much easier notation to write this. You can also write them in this way. It is u suffix x is equals to v suffix y, and this notation will now become u suffix y is equals to v suffix x in the negative sign. Okay, with the negative sign. So these are Cauchy Riemann equations. Now this becomes one. Now we go for the main part. Again we revisit what is analytic function. So analytic function we again take up. So the first thing is here that a function, let's say a function f of z, okay, equals to u plus iv is said to be analytic. Okay, is said to be analytic if and only if, okay, if and only if we have number one, or we can write here a criteria kind of thing. Let's say a, first thing, that is Cauchy Riemann equations are satisfied satisfied and second condition is And the second condition is the partial derivatives. The partial derivatives ux, uy, vx, and vy must be continuous, or you can call it should be continuous. If this happens, then the function becomes analytic. Now this is basically the main part. Now analytic, this is a kind of a criteria, the characterization of a function to become analytic. Now in the world of mathematics, this conditions which I have told you, that a function f of z is said to be analytic if and only if Cauchy Riemann equations are satisfied and the partial derivatives are continuous. Okay, so these are termed as largely as necessary and sufficient condition. Okay, I'll just mention here that this, the first condition is a necessary condition. This is a necessary condition, and the second one is a sufficient condition. So if these two conditions together are satisfied, then the function becomes analytic. And I have tried to simplify this definition as much as possible so that students benefit out of it. Okay. Now one very important thing here that I want to tell is that these Cauchy Riemann equation are also known as CR equations. Okay, they are also called as CR equations. And in our main definition of analytic function, I would like to tell you here that a function, whenever we call it as analytic function, there are few terms involved here. Analytic function is also known as, we can write here and keep it just as a safety purpose, that analytic function are also known as sometimes they call it regular functions, regular, or there is a name called, which is very popular in mathematics, which is called holomorphic. Okay, holomorphic. And this name is not quite popular, but then some places they use this, or this is monogenic. Monogenic. Okay? Monogenic is the word also used. So analytic functions are, I sometimes called as regular functions, holomorphic functions, or monogenic functions. Okay, now the points, uh, like I'll give you this in another part or year in the a different color. The points at which the function f of z is or is not analytic, is not analytic. Okay, they are called points at which, okay, the points at which the function is not analytic, uh, I would rather say here it is, are called are called singular points. Okay? So these points you can remember all throughout, and that is what is my goal. So that, because these are the technical mathematical terms which you will see all across the standard books if you refer, or whereas in the mathematical community they are very popularly used, and they are always there. Okay, so these are the important part regarding analytic function and the Cauchy Riemann equation. So what we have learned is the main definition of analytic function along with its names: regular, holomorphic function, monogenic. It's not very popularly used, but then you can keep it handy. Another thing is that we also got to know what are singular points. Then the one in which we can actually work with the definition, the Cauchy Riemann equations we got, and then we got a very important definition of analytic function where we can actually use it. So a function f of z equals to u plus iv is said to be analytic if and only if we it satisfies the Cauchy Riemann equations and the partial derivatives are continuous or they must be continuous. Okay, so this is one very important definition. Now after this comes one very important formula. We go for a very important formula for derivatives of the function. So now when we want to calculate the derivative, formulas for derivative we can write formula. mm, I'll just take here formula to find the derivative of analytic of an analytic function. An analytic of an analytic function. So the first formula is the number one. Let's say the first one, we already have this here, that f of z is equals to u plus iv, right? So when we take the derivative over here f dash of z, then it is equivalent here ux ivx. Okay, so you can call this as dabba u by dabba x plus I times dabba v by dabba x. Now we already have with us the CR equations. The CR equations are, we just saw them, that the ux is equals to vy and uy is equals to minus of vx. So from these we derive more formulas here, and the first formula which we have just written, then the formula for f dash of z changes to ux is become vy, so we now have vy plus I times vx. So we get a new formula, that is dabba v by dabba y plus I times dabba v by dabba x. This is the formula. Now the third formula that we go for is f dash of z. We already have the formula for ux plus ivx, right? So vx is now nothing but the, if we can shift this minus sign on the other side from here, if it goes here, then it will become minus of I times uy. Okay, so that was the formula that we get from little twisting of the Cauchy Riemann equation. Then we have over here, it is dabba u by dabba x minus I times dabba u by dabba y. So these are the important formulas. Now one more version is possible. So the fourth version, which is there, f dash of z, okay, it's a dash here, f dash of z is equals to, now see, we have all the versions with x x y x x y. Now one with y y we will see. So we have the last version is vy, and it will be minus of I times, just a minute, it will be minus I times uy. So this is the last version in which we have this formula, and it says dabba v by dabba y minus I times dabba u by dabba y. Okay. Now there are four formulas. Now out of these four important formulas, the largely used one are going to be the following: the first one, the second one, and the third one. And amongst all these three, the most used are these two. Okay, so they help us because uh, they will be very helpful when the imaginary part or the real part is given to us. So these are some important versions. You can keep them star or write the thing, it will help us. So in this video lecture, this was all that I wanted to discuss with you people regarding analytic functions. In next video lecture, I shall see you with various kinds of problems, how to solve questions based upon analytic functions and the following formulas. Till then, keep solving good amount of mathematics. Thank you for joining in. Please do like, share, and subscribe to my channel, and share it with your friends, those who find it useful. Thank you.